All right, so I want to watch this together and then I want to talk about it because I think that this helps illustrate it better than I could do with a PowerPoint.
At the site of vessel injury, the first platelets arrive to start sealing the wound. Simultaneously, the coagulation cascade with its various coagulation factors is activated. This involves two pathways, the extrinsic and the intrinsic pathway. Extrinsic activation begins with now exposed molecules of the vessel wall, such as tissue factor, which forms a complex with factor 7. Finally leading to the activation of factor 10. This factor 10A is the point at which the extrinsic and the intrinsic pathways of the coagulation cascade meet. The intrinsic pathway consists of various coagulation factors activating each other in a chain reaction. At its end, a complex with an additional cofactor is formed. This complex now activates factor 10. Since the two pathways merge at the level of factor 10A, this factor has a pivotal role in the coagulation cascade. Further down the cascade, factor 10A, in combination with 5A, activates thrombin and induces the so-called thrombin burst. One molecule of factor 10A can catalyze the formation of 1,000 molecules of thrombin. These large amounts of thrombin cause the further activation of platelets and the enhanced formation of fibrin. Fibrin then forms strands, making up the mesh that stabilizes the platelet plug in an arterial clot and holds together the red blood cells in a venous clot. It can be concluded that the central role of factor 10A in the coagulation cascade makes it a viable target for therapeutic intervention in pathologically altered blood coagulation.
Okay, so that was interesting. I do not care that you know all of the different parts of the clotting cascade. That's not important to me. I just want you to know that watching all the little platelets glob onto each other and seeing how the fibrin forms from the fibrinogen is a good part. All right, so here's the thing. You can't have your clot be there forever. So the tissue starts to heal underneath the clot. So a clot is really just like in your blood vessel is like a scab in your blood vessel. And so it actually becomes problematic at the end of the process because outside of your body, you have a scab. And you've all probably been a kid and had a scab, or like you're still kids and you still fall down, or you still do dangerous things and get cuts. And you're probably familiar with the fact that as the clot actually works a little bit like stitches in that it pulls together and gets smaller over time. That's by design, and it helps the blood vessels or the tissue underneath the clot heal, and it pulls it, like knits it together. And that's good, but then at the end of the process, if you have a scab, the scab falls off. But what happens if it's inside your body? So after this retraction part, you need to have something else happen because if a clot falls off inside your body, it's called a thrombosis, and it can go to, if it lodges in a blood vessel, it can block blood and it can cause death. And it can cause an embolism. I had my lab partner in college died of a pulmonary embolism. Just like, she was like 18. So that's like a bad things happen to people just sometimes. So just don't worry about that. It will probably not happen to you. But it is something that, just if you have a large clot, it's something that can happen. And when they do it, they call it throwing a clot. So your body has a process to deal with this. Once the healing has sort of commenced and is well underway, your body makes enzymes that break down the fibrin in clots and make it into very small pieces, so you don't have that clot break off and lodge in the blood vessels, called thrombosis. Clearly, externally, it's no big deal. It just falls off, and you have new skin underneath it. All right, so that ends blood vessels and blood and all of the good things you need to know. Please take pictures of all of your notes and submit them to me for credit.